So I'm going to have you try these. So they're already set up for you. You're multiplying that outside number by everything on the inside and bringing down the plus signs. This one has a subtraction sign. That's okay. Just bring down a subtraction sign. Remember, you can add and subtract just constants, not coefficients and constants. So like for part C, when you're done with this, if there's two constants, you can add them together. You cannot add constants with coefficients. Keep that in mind. So pause and try these three. This will be another three that I'm looking for. Now we're going to apply the distributive property to an actual real-world problem. So let's take a look, and then I'm going to give you one to try. So make sure you watch this one first so you know how to do it. It says Jose is X years old. His brother Felipe is 2 years older than Jose. Their aunt Maria is 3 times as old as Felipe. Write and simplify an expression that represents Maria's age in years. So what I'm going to do is write a first initial everybody here. So Jose, Felipe, and I'm just put Maria. Okay, so we don't know how old any of these people are, so we're going to use X. So Jose is X years old. So when X represents his age. Felipe is 2 years older than him. So we don't know how old Jose is, but we know Felipe is 2 years older. So whatever Jose is, we would add 2 to it to get to Felipe's age. Maria is 3 times as old as Felipe. So basically, you're doing 3 times Felipe's age, which is X plus 2. So there's how we would figure out Maria's age. Now, if you want to simplify this using the distributive property, you're going to multiply 3 by all of the numbers on the inside. So 3 times X is 3 times X. 3 times 2 is 6. Bring down the plus sign. So this algebraic expression would tell you how old Maria is if you know how old Jose is. So for example, if Jose was 5, let's pretend Jose is 5. Felipe is 7, because 5 plus 2 is 7. You would fill this in. Jose is 5. 5 times 3 is 15, plus 6 is 21, so the aunt would be 21. So that's how you would do that. You don't have to solve it, but that's how you would. Okay, so let me see if I can give you one to figure out. See if you can try the same exact thing here. So now they're telling you that Maria is X years old, her father is 25 years older than her, and her grandfather is 2 times older than her father. Write and simplify an expression that represents Maria's grandfather's age in years. So start by writing an M for Maria, an F for her father, and a G for her grandfather. And do it exactly like I just did the last one. See if you can figure it out. Pause and try this one. Last thing, and I didn't put this on the notes, but I'll just go over it with you. So simplifying when you have 2 variables that are the same exact letter. Well, when you're doing that, you can actually, it's called combining like terms. Like terms means variables that are the same exact letter. So what you can do is, if you have 2 variables but they're the same letter and they both have coefficients, or if they don't have coefficients, because remember the coefficient's 1 if there isn't one, you can add them together. So, or you could subtract them together. So 3x plus 2x would be 5x's. Okay, now if I bring down the rest of the problem, I have plus 9 and minus 5. Now I have 2 constants. I can subtract them. 9 minus 5 is 4. So my final simplified version is 5x minus 4. Okay, or actually, sorry, plus 4, because there's a plus sign here. So plus 4. So again, you cannot add the constant with the coefficient, but if you have 2 coefficients of the same type of letter or variable, you can add and subtract those. It's a little bit confusing. Part B, we have 3 y's. They would all have a coefficient of 1. Y plus y is 3y. So that would be simplest form. This one's a little bit tricky. They threw the distributive property in here. So I'm going to do the distributive property first. So 2 times z is 2z. 2 times 5y is 10y. And this time I have a minus sign, so I'm going to bring down the minus sign. Now I'll bring down the rest of the problem. So now I have z's that I can actually do something with. Oh, this is a z. I don't know why I put an x. This is a z. So I have 7z plus 2z. I can add that and get 9z's and then take away 10y. Again, I can't do anything with the 9 and the 10 because they're both coefficients of different letters. If they're the same letter, you can do something. If they're not the same letter, you can't. So this would be my final answer for that one. So I did the distributive property first. 2 times z is 2z. 2 times 5y is 10y. They had a subtraction, so I brought that down. Then I brought down the rest of the problem. I could add these because they both have the same variable. 7z's plus 2z's is 9z's. Then take away the 10y. Cannot combine these because they're different letters. So let's see if you could try these. These ones are a little bit tricky. See if you could try these just like the one that I did. So again, you want to pause and do all three of these. It might be easier to write out the actual problem first and then kind of figure out what you can add and subtract. Remember, you can only add coefficients if they are with the same exact letter, okay? You can always add or subtract constants, but if you're talking about coefficients, you can only add those if they're attached to the same type of letter. Okay, the last three, so try these.